Alright, here's my plan. I've moved the cutter off to the right, and what I'm going to do is I'm going to raise the table up. I'm going to put the head in neutral so I could spin the cutter easily with my hand. I'm going to bring the table up. I'm going to bring the table up so that I know that the side of the cutter is below the surface here on the side. I'm going to take up the lost motion in the table, and I'm going to turn this until the side of the cutter just kisses the side of my aluminum block here. Right there. Okay. Now I'm going to bring the table down, and I'm going to set my dial over here at 0. Now I'm going to crank the table over 840 thousandths. So each time around is 200 thousandths. That's 840 thousandths right there. And at that point I'm going to lock my table. And just eyeballing it, I can see the edge of my cutter is right over my idiot line, so I feel pretty good about that. So the next thing I got to do, supper's ready. Now I want to take a cut 70 thousandths deep, but I'm not going to do it all in one pass, so I think what I'll do is I'll do 30 thousandths, 30 thousandths, and then 10 thousandths. So what I'm going to do is, again, I still got this in neutral, so I'm going to bring my knee up, bring this closer to the edge. And that should be within 1,000th. Lock the knee. No, I'm not locking the knee. What am I doing? Yeah, I'm locking that knee. I'm going to set the dial on 0. And I'm going to take this back a little bit. Get my safety glasses. Oops. Got to put it back in gear. Ah, pain in the butt. Ugh. There we go. Oh, 70 thousandths. Let's take 20. More. And that'll be 70 thousandths right there. Alright, fluorescent lights were off over here while I was up having supper, and they take a long time to come up to full brightness because it's a little cool down here in the basement. So I don't know how good this is going to show up, but I just test fit this and found out that I'm not where I want to be. There's still, oh wait a minute, no. I stand corrected. I think what might be going on here is there might be, there's a little bit of a taper there. probably wouldn't hurt to make this actually just a little bit wider. I think there's a little bit of a taper to the side here. Because when I drop this down just a little bit, the fit gets a lot better. You know, in reality, I could leave it just like that. I think I'm going to leave it alone. So the next conundrum is going to be getting these holes drilled in the exact correct spot. And I know they make these little like points that thread into the holes and give you a little sharp point sticking up, and then what you do is you put the part over the two little nubs, tap it with the hammer, and it'll leave you two little dimples right where your center point's going to be. And those would be perfect right about now, but I don't have those in my arsenal. So what I think I'm going to do, see if I can't find the broken piece of the bracket, if I still have it laying around here, and use that with some transfer punches. There we go. Alright, I've got a center drill in my drill chuck, and I'm using magnification so that I can get that point of the center drill to go right into the little dimple that my transfer punch made. And it looks good in that direction, so I'll lock the table there. Lock the table. Looks good. Alright, now without changing any of my positions, other than lowering the knee to get a drill bit in there, I'm going to pop a 1/4 inch drill bit in there, drill that hole, move this back up this way, drill this hole, and be done. I guess I should have seen exactly how far it was between these two holes using the dial, then I could come back this way. And, well, you know what, with the DRO, I'd probably screw things up because of the lost motion in the, without a DRO, I'd probably screw things up because of the lost motion in the lead screw for the table. Oh well, I'll manage. Glad I caught that in time. Alright, so I've mounted that aluminum block in there, now that I get the first part partially done. And I did the same trick with the 1, 2, 3 block on the side there. And so now I'm going to start off by squaring off the top. And I want to do it in one pass. So I was going to use this big mill that I've got here, this three-tipped indexable carbide cutter that I was using. I was using this last time on the stainless steel. Looks like I damaged the teeth on this now that I look at it. That must have been when I saw those sparks flying off. Anyways, live and learn. And then I was just looking through my stuff, and in one of the toolboxes that had a whole drawer full of end mills and everything, there was this little miniature facing cutter. It's like a smaller version of that thing. And that will be wide enough. Alright everybody, before the battery died on the camera, I face milled one end of this block and then I flipped it over in the vise and took a cut to straighten it out. So now I've got two nice flat surfaces, and this block is still too long. So I think what I'm going to do, I haven't decided yet how long I'm going to keep that. I've got to keep it, well, let me back up for a second here. Alright, so the main part of the block has to be as long as the bearing is. I can't have it longer because then I won't be able to put the nuts on the end that actually retain that lead screw from just moving out. So I've got a certain dimension I've got to play with here. So I could just make the whole block that size, but I'm toying with the idea of leaving almost like a bracket part hanging off the extra here, and possibly locating a countersunk screw from the front to hold this in place. So I don't necessarily want to cut this whole block down just yet. Alright, so I scribed a couple of lines on here, and the top line is where I want to, that's the length I want to cut the whole entire block down to, and the second line down is where I want to cut the block down so that I end up almost like with a bracket hanging off the end here. It's probably easier to just show it than explain it. Alright, so I'm going to modify the design on the fly here. And what I'm going to end up doing is, I only need this block to be the full dimension this long for the bearing. But I'm going to leave this extra on here, and I'm just going to mill out a section here and leave this narrow piece long as an attachment point. So what I want to do is to figure out how much I'm going to mill out. I know I'm going to mill down to this line and then over to a certain point. To figure that out, I've got to locate where my bearing is going to be. So I'm not going to put the bearing dead center, because then I won't be able to offset this like I want to do. So I want the bearing to be off center this way, centered this way. So I think what I'm going to do is I can't put it all the way up to the edge here obviously, because then when I drill my hole there'll be nothing supporting it on the outside here. So I think what I'm going to do is I'm going to have this in from the edge, probably the thickness of the bearing. And so what I could do is I could take the dimension of the bearing and add to the dimension, the OD of the bearing, add to that 2 times the thickness of the bearing wall. So bearing wall is 124 thousandths. 125, alright, that makes sense. 125 thousandths. The bearing itself is 627 and a half. So I'll call that 627. 125 and 125 is 250. 627 plus 250. $877. Probably could have did that in my head, but 877 thousandths. So what I want to do is, when I say 877 thousandths, so 877 thousandths, that doesn't give much of a, that doesn't give me much of a, oh, look at that, idiot. Doesn't matter, because I think I'm gonna abandon that plan, because that only gives me this very thin area to deal with here. Yeah, it's gonna be such a thin piece, it's not worth it. Alright, so we're gonna go back to the original design plan, which is this whole block is just gonna be this long. Period. Well, I bet you by now somebody has already stopped watching the video and is feverishly typing a comment to tell me that I'm doing this wrong, because I've got this facing mill in here, and I just took a ton of passes to mill this down to this line, and it just occurred to me, now that I have to go even further down to this line, it's going to take me a month of Sundays to do it with the facing mill, because the facing mill is not the right tool for this job. If I was only just smoothing off the top there, facing it, duh. So, it's like magic. Without even seeing that comment, it dawned on me, duh. So I need a roughing mill, I believe, is what I want. So we'll go in search of a roughing mill. So this is a roughing mill. You can see that it's got these serrated edges here. So this is for hogging out larger amounts of material, and this is used when you want to remove more material quicker and you're not as concerned about finish. So what I can do is I can throw that facing mill in when I get down near the end there, take my final cuts with that, end up with a nice finish on the end. But as far as for right now, I'm getting rid of larger amounts of material more quickly. I'm gonna go with this. Alright, so the direction of this cutter is going to be this direction. So going from left to right should be climb milling. In other words, yeah, that's climb milling. That's what I want. No, which one's which? Conventional milling? This will be conventional milling, with the cutter rotating this way and the work fed into it this way. That's conventional, that's what I want. Climb milling would be if I was coming from this direction, and as the cutter's turning that way, it's actually wanting to pull the work in the direction of the feed, which I don't want. Alright, now that we get that straightened out. How much can I take off with this thing? Wrong way. Gotta get the chips out of the way so I can see how close I am. Gee, you know, for a roughing mill, I guess because my speed and feed is pretty conservative, I'm not getting too aggressive with it for the most part. That's like smooth as glass. So I guess also it helps that it's aluminum. But yeah, I don't think I'm going to need to change out to that facing mill. I'm just going to keep going with this and finish right. Finish what I started. I'm still 30 thousandths too long. When I tighten that nut up, I want the nut to be bearing on this end of the bearing here, not on the block. So I actually would want the block to be... Oh, wait a minute. Oh, that's interesting. There's only 4 thousandths that way. I think what I'll do is I'll take 5 thousandths off this side that I haven't milled. That's the ticket.